So let's talk about these inverse trig functions. So if I say, um, well, some, I'm going to say inverse, but a more formal term is arc sine. Okay, so arc sine is the inverse of sine. Um, so again, if I have a triangle, a right triangle like this, or this is angle A, um, for angle A, I'm going to have the opposite here. This is capital C. This would be the hypotenuse, and this would be the adjacent. The reason for that is the hypotenuse is across from the 90-degree angle, right? The opposite is the side that's across from the angle that we're interested in, and the adjacent is the remaining side. So if I say that the sine of A is equal to the opposite over the hypotenuse, then if I say arc sine of A is equal to arc sine of the opposite over the hypotenuse. Okay? Now what happens is the inverse undoes what the original trig function is doing. In other words, this cancels with this, and I'm going to get the measure of angle A is equal to arc sine of the opposite over the hypotenuse. Okay? So now let's do arc cosine. So if I say arc cosine, that's going to be the inverse of cosine. Now that's going to be the exact same thing. If I say cosine of A, that's going to be equal to the adjacent over the hypotenuse. And if I take arc cosine, or the inverse of cosine of one side, whatever I do on one side, I have to do to the other. Okay? And then this cancels with this, and I'm just left with the measure of angle A is equal to cosine of the adjacent over the hypotenuse. Okay? Lastly, arc of tangent, that's the inverse of tangent. And so if I say tangent of A is equal to the opposite over the adjacent, and I take the arc tangent, or the inverse of tangent of one side, then I also have to do it to the other side. And that leaves me with the measure of angle A is equal to the inverse of tangent of the opposite over the adjacent. And so that's basically how we're going to do this. So let's just a real quick recap. On the top here, arc sine, so this is the same triangle for all three figures, but sine is the opposite over the hypotenuse. That's where we get the so from. And then if we take the inverse of both sides, I can find the measure of angle A by taking the arc sine of the opposite over the hypotenuse. The same with cosine. Cosine is the adjacent over the hypotenuse. That's where the ka comes from, for so ka toa. Same thing, the cosine of the adjacent over the hypotenuse will give me the measure of angle A. But remember that the adjacent and the hypotenuse have to be the adjacent and hypotenuse of the angle A. Arctan, the exact same thing. Tangent is the opposite. That's the TOA over the adjacent. And then if I take the arctan or tan inverse of the opposite over the adjacent, that will also give me the measure of angle A. So we're going to get a lot of questions today, and you're going to have to determine which one do I use. Do I use arcsine? Do I use arccosine or arctangent? And the clue is, do you know these two ratios? If you do, then you would use the inverse of sine. Do you know these two ratios? If you do, then you would use arccosine. Do you know these two ratios right here? If you do, if you know these two ratios right here, then you would use arctangent. Okay? So let's go ahead and do example number 2. So now for example number 2, we are given tangent of A is equal to 0.75. And then we are given another example. Well, we'll just do one example at a time. So now, to find the measure of, find the angles, that's what we're asked to do. I'm just going to take the inverse tangent of this. So I'm going to say the tan inverse of the tangent of A is equal to the tan inverse of 0.75. Now, they didn't give us a ratio. Technically, the ratio is 3/4, but that's okay. We don't need to know that. So then the measure of angle A is equal to this right here. So I'm going to plug that in my calculator. And I'm going to get arctan of 0.75. Close my parentheses. And so if I were to round that to the nearest tenth, I would get 30. So if this is, if I'm round to the 10th and this is the 10th spot, I go one space over. It's a 6. That's 5 or higher. So I'm going to round this to 36.9. So this is approximately 36.9 degrees. And I'm going to change that from an equal sign to approximation sign. That wasn't that hard. So now for that was part A. For part B, we're going to do one of each of these. So if I say sine of capital letter B is equal to 0.87, again, I'm just going to say the arcsine of sine of B is equal to the arcsine of 0.87. These undo each other, so I get the measure of angle B. In other words, this cancels this. Is equal to the arcsine of 0.87. It equals, so that is 60. Again, if I want to round to the nearest tenth, the 4 is in the 10th spot. I go to the right. It's 5. So that means I'm going to round up. So it's going to be approximately 60.5 degrees. For part C, I'm given cosine of C is equal to 0.15. Again, I'm just going to say arccosine, or the inverse of cosine of C, is equal to the cosine, or arccosine of 0.15. These cancel out over here, and I'm left with the measure of angle C is approximately, just plug that in the calculator, and 81.4. And that's it.